today we're going to start talking about the atom and how it's different from an element, how it is important, how it is organized, and the history behind it and all that fun stuff. So the first thing to understand is, what is an element? And an element is simply a substance that cannot be broken down into simpler chemical substances. Basically, if you look at the periodic table, those are all the elements. Everything is made up of elements, and all elements are made up of atoms. Atom is the smallest particle of an element that retains its physical properties. So atoms build elements, elements build everything else. So those are how the two are related. So we're going to look at this beautiful timeline. I know we looked at it in crash course chemistry, but it's also important to take a look at the timeline. About 2,000 years ago at 460 BC, Democritus thought up the atom. He just thought he could cut and cut and cut and cut and cut, and eventually he get to a place that couldn't be cut anymore, and he called them atomos. Unfortunately for history and for science and for chemistry, Aristotle came along and said, well, that's stupid. That can't possibly be true because I can't see it. And therefore, the jerk, who shall forth in this class be called Jerkistotle, stopped the history and evolution of the atom for about 2,000 years. Dalton kind of rethought about it. Thomson came up with the plum pudding model. If you are unsure what plum pudding is, think of it like a chocolate chip cookie. The dough would kind of be where the electrons are, and then the chocolate chips would be like where the protons are. They thought it was all throughout. Then Rutherford proved that that is untrue. He shot protons and alpha particles at a gold foil in the gold foil experiment, and it bounced all over the place unexpectedly. And he changed to a nucleus in the center. Bohr came up with a planetary model where he likened the atom to planets, whereas the planets are heliocentric. That means they're circling around the sun. He thought that atoms were proton-centric, where everything circled around the proton. And then that moved to the quantum model, which is just a big cloud of electrons. If you play Mario Kart and you have that little turtle on the cloud guy that like fishes the people out, and that cloud underneath him is very reminiscent of the cloud model. Moving forward, we're going to talk about who discovered the electron and how it was discovered. So, Sir William Crookes in a cathode ray lab. And if you're unsure what a cathode ray is, it's really an early version of a neon light. It's a tube in which they put inert gases, and then they shot electricity through them from positive to negative, and it changed color. They did this with a lot of different gases. He changed the electrode, the type of gas, but they always changed color. And from this, because they were shooting the negative stuff through it, he decided that everything had negative charged particles in all forms of matter, and these are called electrons. He discovered electrons, and we use them as neon lights, a more advanced type of cathode ray, which is very cool. I like neon lights. Then we have Sir Robert Millikan. He was an American physicist who determined the charge of an electron to be -1, and also the mass of an electron to be 9.1 times 10 to the negative 28, or a relative mass of 1 over 1,840th mass of a hydrogen atom. That's very cool. He did an oil drop experiment where he atomized the oil droplets and made them into tiny particles. He then ionized them and put them through a charge plate of both positive and negative, and through all of this scientific magic, discovered the charge of an electron. Then came the big breakthrough. This was Rutherford. Rutherford was determined to figure out things about the electron that he thought he knew. He was trying to prove the plum pudding model, but we came up with the Rutherford model instead. So he had this generator here that he was shooting at gold foil. He expected it to go pretty much through some and then bounce on others at very similar increments. What instead happened was at certain areas it bounced almost back completely, but for the most part it bounced through. Did not act as expected. Because it did not act as expected, they figured out that there were areas of very dense positivity and large areas of nothing. And this is how we came up with the first model with a nucleus. And this is how Bohr built on that, and the quantum model built on that. It all started with Rutherford. And if we look at this, this is a good Bohr model. Now, I know that the Bohr model is not the most common model, but in chemistry, we really use the Bohr model because it's a nice way of showing what we know without throwing dots all over the page, because that would be very confusing. So in the center of the atom is a nucleus. Here's your nucleus. It has positively charged protons and no charge neutrons. So with no charge plus charge gives it a positive charge. Circling around the nucleus, or jumping around if you like the quantum model, you have high-speed electrons. Electrons are negatively charged. In an atom, not an ion, in an atom in and of itself, there's the same amount of protons as they are I cannot talk. Protons and electrons are the same amount. So when you have the same amount of positive and negative, they cancel out. So the charge of an atom is always neutral or no charge. Then we're going to talk about a very important slide that I know you're going to screenshot, take pictures of, and learn to love. Let's talk about the three most important parts of an atom. The proton, which is found in the nucleus and is positively charged. The electron, which is found in the space surrounding the nucleus and is negatively charged. Please note, protons never leave the nucleus and electrons never enter the nucleus. And then you have a neutron, which is found in the nucleus and is neutrally charged, which means it has no charge. So let's break it down even further. You have an electron, and the symbol for an electron is E negative. It's located again in the space surrounding the nucleus. The relative electrical charge of an electron is 1 minus. The relative mass, meaning compared to everything else, like proton and neutron, is 1 over 1,840, but the actual mass is 9.11 times 10 to the negative 28th. The proton and neutron are somewhat similar. They're both found in the nucleus. The proton is small p with a superscript positive. The neutron is a big N with a superscript 0. The relative electrical charge of a proton is +1, and the relative electrical charge of a neutron is 0. So if we're looking at an atom and we know electrons and protons are the same, they will cancel each other out because the relative electrical charges will always be the same in both negative and positive. The relative mass of the proton and neutron of 1 each, which means their actual mass is actually incredibly similar. It's 1.673 times 10 to the negative 24th for the proton and 1.675 times 10 to the negative 25th for the neutron. This is the basic stuff that we will start building chemistry on. So let's talk about the final important part of being able to understand the pieces of the atom, which is being able to read the periodic table. So I've all given you the downloadable periodic table. And when you look at that, on every element like square, you can find the chemical name, fully written, does not matter if it's capitalized or not. The chemical symbol, which is caps sensitive, so you got to pay attention to the caps. The atomic number, and the average atomic mass. Now we'll be talking about that later this unit. But that in and of itself is the first introduction to the atom.